Helium is not a party gas. It's a finite, non-renewable elemental asset, and right now it is holding the world's most advanced computing infrastructure hostage. In early 2025, the United States completed the sale of its Federal Helium Reserve, the Cold War-era stockpile that once buffered the entire Western world against supply shocks. It's gone, sold to a private industrial gas group. At almost the exact same moment, the global helium market has entered its fifth major supply crisis in 2 decades. Qatar's largest export facility has been damaged, Russia has restricted exports, and China has banned them outright. By the end of this video, you'll understand the physics of thermal collapse, the 30-year policy decision that dismantled the West's strategic buffer, and the live geopolitical scramble now unfolding over what's left. Here's the mechanic. Advanced chip manufacturing, the extreme ultraviolet lithography systems used to print sub-3 nanometer transistors, and quantum computing both depend on one extreme condition: near-total molecular stillness. At room temperature, atoms vibrate constantly. That vibration is thermal noise. Picture trying to take an ultra-high-resolution photograph while standing on a moving train. Even a tiny shake blurs the image completely. That's thermal noise at the atomic scale. Constant, invisible vibration that ruins precision the instant you try to work at a small enough scale. In lithography, that vibration degrades the precision tools patterning a chip atom by atom. In quantum computing, it's fatal. In a quantum computer, data processing units, called qubits, must stay perfectly suspended in mid-air to run calculations. Introduce even a microscopic wave of heat, and it acts like a sudden gust of wind, slamming the units into the floor and erasing the data instantly. This sudden system crash is what engineers call decoherence. Think of the entire global computing pipeline as a hyper-fragile glass refrigerator. If the internal temperature drifts by even a fraction of a degree, the system doesn't slow down, it shatters. Billions of dollars of infrastructure gone, instantly. Liquid helium at negative 269 degrees Celsius, a few degrees above absolute zero, is the only substance on Earth cold enough to run this refrigerator continuously. There is no synthetic backup. Hydrogen liquefies at a higher temperature and is explosively flammable in cryogenic use. Nothing else on the periodic table stays liquid this close to absolute zero. This isn't a supply chain problem you can engineer around with a substitute material. It's a hard, physical constraint. Now, here's how the West lost control of that constraint. In 1925, the United States built the Federal Helium Reserve outside Amarillo, Texas, storing gas extracted as a byproduct of natural gas drilling across the Qubit field, which at its peak held more than 95% of the world's known recoverable helium. Through the 1960s, the government built a 425-mile pipeline network feeding an underground geologic structure called the Bush Dome. For decades, it was treated the way you'd treat a national defense stockpile, insulated from short-term political pressure, tied to airship surveillance, and later to aerospace and defense applications the Cold War depended on. Then, in 1996, Congress passed the Helium Privatization Act. The reserve, which at the time held over 30 billion cubic feet of helium, was ordered liquidated by 2015. Sold off to pay down the debt originally used to build it. Here's the mechanic of the damage, and it's more specific than the government sold gas too cheap. The 1996 law pegged the sale price to general inflation, roughly 3% a year, completely detached from actual market value for helium. That single pricing formula did 2 things simultaneously. First, it flooded the market with artificially cheap federal helium for nearly 2 decades because a government-mandated seller has to sell, regardless of market conditions. Second, that price ceiling made new private helium extraction and separation infrastructure uneconomical to build. Why would a company sink capital into a new cryogenic separation plant when the federal government was legally required to keep dumping underpriced gas onto the market? Congress didn't just sell the reserve. The pricing mechanism built into the law quietly strangled the industry that should have replaced it. The Helium Stewardship Act of 2013 finally corrected the formula, moving to market-rate auctions. But by then, the damage to domestic reinvestment was structural, not cyclical. The liquidation dragged on for almost 3 decades. In early 2025, it finished. The federal government's remaining helium assets at Amarillo were sold outright to the Mesa Group, a private industrial gas company. The stockpile that once made the United States the buffer of last resort for the entire non-communist world no longer exists as a strategic asset. It's now inventory on a private balance sheet. Picture helium atoms as microscopic green mist, small enough to slip directly through solid steel over time. That's not a metaphor for effect, it's physically true. Helium is the second lightest element in the universe, and its atoms are small enough to diffuse through containment that holds every other gas without issue. Now picture the reserve itself as an iron safe, with a slow structural crack running through it for 30 years, until, in early 2025, someone finally opened the door and sold what was left. The West had systematically traded a foundational physical asset for short-term balance sheet relief. Tracking these hidden systemic blind spots across global supply chains requires deep data mining and clinical production. If you value this level of zero-fluff institutional analysis, take a second to look below the video, hit like, drop a comment on the supply chain, and subscribe to support the channel's growth. Now to the current battlefield. And this part isn't historical, it's happening in real time. Global helium supply has concentrated around 3 producers, the United States at roughly 43% of global output, Qatar at roughly 1/3, and Russia in 3rd place. Qatar's helium is extracted at the Ras Laffan facility and shipped almost entirely through the Strait of Hormuz. The systemically fragile Ras Laffan facility has repeatedly buckled under operational shocks, cutting global export capacity by an estimated 13 to 15%, with repair timelines running 3 to 5 years. Spot prices for helium roughly doubled within weeks. Russia, meanwhile, has been building the alternative. Gazprom's Amur gas processing plant in the country's Far East is now the largest helium production facility on Earth, designed for 60 million cubic meters of annual capacity, built without a Western technology licensor after the original partner exited the project. Since April, Russia has required government approval for any helium export outside the Eurasian Economic Union, restrictions expected to hold through 2027. That control point alone gives Moscow direct leverage over a resource none of its buyers can substitute. Then, this July, China banned helium exports outright. China imports more than 80% of the helium it consumes, and the ban isn't about controlling global supply. It's about protecting its own chip fabrication and medical imaging sectors from the Qatar shock. China had already begun building its own strategic helium reserve in 2024, in depleted gas reservoirs in Shaanxi province. The same defensive move the United States made a century earlier and just finished unwinding. Here's the bottleneck, mapped by sector. Aerospace manufacturing uses helium for pressurizing rocket propellant systems and for leak detection in fuel lines. You cannot launch without it. Every MRI machine on Earth uses liquid helium to keep its superconducting magnets below their critical temperature, and hospitals are already facing tighter allocation. Fiber optic manufacturing and semiconductor fabrication use helium as an inert cooling and purging gas throughout production, and quantum data centers cannot operate their dilution refrigerators, the systems that cool qubits to fractions of a degree above absolute zero, without an uninterrupted cryogenic helium supply. None of this can be reshored the way you'd relocate a factory. You can build a new fabrication plant in 18 months if capital and permits align. You cannot build a new helium field. The gas is either present underground in economically extractable concentration, or it isn't. Geology does not respond to industrial policy. And the quantum sector specifically has almost no slack to absorb a shock like this. A dilution refrigerator, the machine that cools a quantum processor down to roughly 10 to 15 millikelvin, a fraction of a degree above absolute zero, runs on a closed-loop mixture of helium-4 and the rarer isotope helium-3. Helium-3 isn't a byproduct of natural gas extraction at all. It comes almost entirely from the decay of tritium in nuclear weapons stockpiles, which makes it not just scarce, but structurally tied to defense sector production decisions in a handful of countries. Every major quantum computing lab, from national labs to hyperscaler research divisions, is competing for allocation from the same narrow pipeline. A helium-4 shortage raises costs. A helium-3 shortage stops quantum hardware programs entirely because there is no substitute isotope and no accelerated way to manufacture more. Picture the Bush Dome Reservoir in Texas, empty and privately owned, while 3 other nation-states, one facility damaged, one under export controls, one hoarding for itself, decide, month to month, how much of the world's remaining helium reaches the outside market at all. Here's the structural summary. Factory buildings are fungible assets. You can build another one somewhere else, given enough capital and time. Elemental scarcity is not fungible. Physics cannot be renegotiated by capital, policy, or political will after the fact. The 1996 Privatization Formula and its early 2025 conclusion weren't a minor accounting decision. They removed the West's only strategic thermodynamic buffer at precisely the moment the next generation of computing infrastructure was beginning to depend on it entirely. And precisely before a supply shock, the West now has no reserve left to absorb. The West faces a genuinely structural challenge. Rebuilding a domestic cryogenic supply chain it spent 3 decades dismantling, with no stockpile left to buy it time while it does. Our next clinical deep dive drops exactly next week. Turn on notifications so you don't miss the next mechanical teardown.